Hey everybody, it's Greenwood again with another tutorial video. In today's video, I will be showing you how to find the missing side in a right triangle using trigonometry. So in previous videos, we talked about labeling right triangles for trigonometry, and we talked about solving for missing angles. So in this video, we'll show you how to find a missing side if that's the piece you need to find. So the process is still very similar to what we just did. So we always start by labeling. My hypotenuse is always across from the 90. My reference angle, I'm going to choose one where I know the degree measure. So I know this is 54 degrees. So I'm going to choose C as my reference angle, which is going to make the side mark with the X as my opposite, excuse me. And then the 19 is my adjacent. Okay, so knowing that now, we need to choose an appropriate ratio. And so remember your SOHCAHTOA. You can look at that from a previous video. I am going to look at the sides that I know and the side I want to find. So they're trying to push me in a certain direction with the X. So the opposite is the side they're trying to get me to find because it's marked with the X. And the adjacent is the side I know is 19. And I know my angle is 54. So opposite and adjacent, if you look at your ratios, that's tangent. So for this problem, tangent is the best choice to solve. I still have a little more room here. So tangent of my reference angle C, but in this case I know C this time, and that's something I haven't seen before. My reference angle is 54 degrees, so I have tangent of 54 degrees, and that's going to equal opposite over adjacent. My opposite is X, and my adjacent is 19. And so you can see I'm using some color to help you see where stuff's coming from, okay? Reference angle, side, side. So again, as you're thinking about trigonometry and this shift to finding sides, you've got the angle on the two sides. You have to know two of the three parts, okay? So before we knew two sides, we knew the opposite and the adjacent, we could find the angle. In this case, we know the angle on one of the sides, we can find the side that's missing. All right, so now let's go through the solving process, which really this is all just some algebra. So my calculator will tell me what tangent of 54 is, so I'm gonna go switch over to my calculator here, and I'm gonna use tangent 54. I'm not using inverse tangent or arctangent here because I know the angle. So I'll just use regular tangent. I use the inverse if I don't know the angle. That gives me this decimal, 1.376, and it goes on for a while. So I'm going to rewrite this ratio or this tangent as 1.3763. Let me double check my calculator, make sure that's correct. 1.3763, that's good. Okay, equals X over 19. And now we're going to treat this thing like a proportion. So I'm going to put this number over 1, and then now I'll do cross multiplication. So I've got that multiplied, and we can do cross products essentially to get rid of the denominator to figure out our solution. So we'll take 1 times X, that's X. That makes things nice and easy. And then I'll multiply this 1.37 number times 19 in my calculator. So I'll pick 1.3763 times 19, and I get 26.149. So that number is the length of the opposite labeled side, so side AB that's marked with the X, okay? So one of the big things you want to think about here is that we're solving for a missing side length this time, not for an angle. Okay, let's look at another problem. So again, we'll go through. Here's my reference angle because I know the angle C is 38 degrees. I like using the arrows. That helps me keep track of what I'm looking at with my labeling. There's my opposite, and here's my adjacent. Okay, again, so as you do this, the question you want to kind of ask yourself is, what is the problem trying to get me to do? And in this case, we're trying to have you find the X, which is the hypotenuse, and I know the adjacent is 17. The opposite I know nothing about. I could solve for the opposite, and that wouldn't be a bad thing to do. It's just not what this problem is geared at finding. They're geared at finding the X in this case. So adjacent and hypotenuse, when I pair those two sides, that's the cosine ratio. So cosine, my reference angle C again, this time it's 38 degrees, so cosine 38 degrees. Make that look like a degree symbol, and now it looks like a 0. That's better. Cosine 38 degrees is adjacent over hypotenuse, so my adjacent is 17. and my hypotenuse is x. Okay, so we'll go type this cosine 38 into the calculator. Cosine 38, and we get 0.7880, 0.7880, okay, equals 17 over x. So again, make it into a proportion so two fractions equal, so that we can do cross products. So we will multiply those two, and we'll multiply these two. So I'm left with 0.7880 times my x equals 1 times 17 is just 17. And so now to solve, we have to divide both sides by this decimal. So since we have that decimal multiplied by x, we're going to play our opposite game and do the opposite of multiply, which is divide. Those don't look like 8s. Let's try again. 8, 8. That's closer. Okay, so now it's just calculator work, and we'll figure out what our missing side is. So I'm going to just write that over here since I kind of ran out of room on my page. So we'll do 17 divided by 0.788 because those will cancel. And 17 divided by 0.7880, and I get 21.573. 21.573. So that's how long my hypotenuse is. It's 21.573. Okay, so that's all there is. I hope this one helped you, and we'll see you in the next video. Bye.